xi is equal ai zi, and hi is equal to bi for zi, where ai and bi are Leontief coefficients and fixed. The more general production function, you have ai and bi function of the relative cost of goods and time, right? And that's one way to write the general production function of constant returns to scale, where the a's and the b's don't depend upon the level of c's. That's what constant returns to scale is. And otherwise, with fixed coefficients, this means fixed proportions. You can't vary the proportions. So it's useful. And then we would have that pi I, average price of zi, is equal to ai pi plus bi w. Okay. And the marginal cost, marginal price, marginal cost, or marginal price equals pi I. Constant returns to scale, the pi and the w are given to the household. So what this shows is that very explicitly that the determinants of the prices of commodities, of the ZIs, depend partly on cost of goods, PI, clearly, but also partly on the wage rate, and also on the technology, the household technology. So if you think of the set of household technologies, the vector of all these equals household technology. In this case, and more generally, in the nature of the production of technology. So they're also important, and I'll give you some examples with they can have an important effect on the choices of the Z's, but also on the choices of the underlying inputs, the X's and the H's. And by allowing household technologies to change over time for a given household, or to differ across households, you reduce the ability to explain apparent differences in choices, even for people of the same income and then even the same wage rate, hourly earnings, how then, without introducing or weighting as much differences in taste or changes in taste over time. So, and a major assumption of consumption theory that often doesn't get emphasized enough is that we assume stability in preferences. So if your price changed, your preferences were changing in all kinds of ways. The basic theorem on negative own substitution effects and all the other theorems would be greatly affected. They could be reversed. So to give the theory content, we assume stability of preferences. It could be a very general notion of what preferences are and stability. But stability of preferences, okay? So then you ask, well, are preferences similar across different individuals, across countries? Well, you see a lot of choices that differ across individuals, even with the same income. So that due difference in preferences, well, this is at least a way of narrowing that, because there, as we'll see, there are important determinants of the AIs and the BIs, or of technology, that will lead to differences in choices and do not have anything to do with differences in preferences. So if you think of the Z's as the basic underlying demands for people, for, as I said, for prestige, recognition, taste for food, and the underlying taste thing, conversation, these will be pretty similar, you think, across people, even across countries. The choices that people make are related to prices, and I would emphasize shadow prices of the commodities and of full income. Okay? Because that's the framework that is pushing it down. Now, household technology not only differs across individuals, but changed a lot over time. You think of, we often concentrate on the technological changes in the market sector, and they've clearly been very important, and maybe even been great. I don't think anybody's been able to answer that question yet. But they've certainly been very fundamental in the household. Think of the small electric motor developed in the latter part of the 19th century that made possible some of these cheap, miniature household durables that we take for granted now. Washing machines, dishwashers, dryers. And you can go on and on with electronic equipment. They were originally started by the electric motor, then we got computer developments, internet access, microwave ovens, birth control pills, very important in fertility analysis, flat panel TVs, TiVo, and you can go on and on. I mean, they have applications in the market sectors that affect productivity as well, like computers, but they also have big effects on households. Okay? So household productivity has changed a lot over time.
And it's not just that those goods have been developed, they've also continued to get cheaper. I mean, one of the striking things is like a washing machine is basically similar in nominal price today as it was in like the late 1960s. Yeah. And so it's amazing when you think about how much cheaper those goods become over time.
Yeah, you think of early washing machines for the household, you couldn't really dry clothing very effectively. I mean, washing machines spills out the water, but they didn't do that in the early days. You had to put them through something that squeezed out the water. You didn't have a dryer. So then you developed a little dryer that's very effective, and you developed such a more efficient washing machine. So Kevin is absolutely right. And a lot of these developments, think of them also as in the market sectors in use. Not just coming from nowhere. Consumer demand will influence the development of these products. I mean, it's pretty obvious if you take any one of them, that anybody who comes up with important innovation can make a lot of money. And so that's a powerful inducement for development. Now also, and I'm going to stress this more, individuals differ a lot in their technology because of differences in education. So we think in abilities of all types, and you can think of many other factors. Now, we usually think, if you think of the human capital analysis, investments in education, almost that whole literature concentrates on the effect of education on earnings. There's very powerful evidence that education has a very big effect, and a growing effect, an effect that grew a lot from 1980. Kevin was one of the first people to document that effect for the United States, and now you see that in many other countries. So that effect is important. But what's less investigated is the effect of education on what I would call consumption or household technology. So for example, we have increasingly good evidence that education is an important in the health, determining health. Simple analysis, you just do cross-sectional relation. Educated people, much healthier, they live longer, and in every dimension of health, they're much better. Now you want to be more sophisticated, try to instrument for education in various ways. People who've done it, not as extensively as in the earnings education relationships, nevertheless find that it's not just causation, for example, from health to education, but most of it is from education to health. So that's been investigated some. And a few other things have been investigated a little bit, and whenever it's been investigated, the education appears to have an important effect on what it usually, by most people, would consider good outcomes. Okay? You mentioned the outcome. Educated people are better at it. I mean, there's hardly anything you can think of that isn't true. That's of any value. So one way to interpret that effect is to say that education, as in the marketplace, raises individuals' productivity, so in the household, greater education raises household productivity. Right? So what are some of the consequences of that? Suppose, we can think of it still within this fixed proportions framework. Suppose there's an increase in education, and if we use, we ask, say there's a change in AI, education, E for education, and I think we introduced that yesterday, E equals education. EAI, let's say proportional change, and education proportionally lowers an increase in education lowers all the AI and BI by the same proportion. Simplest of all effects, right? Neutral within any commodity and neutral across commodities. Right. So an increase in education lowers all these coefficients. Let's say you go from being a high school graduate to a college graduate, you lower them by 10%. So, okay. That all means, what does this imply for what happens to real income? What does it imply for what happens to commodity prices?
Price of pie.
Yeah, pie. Either, what do you think?
Would decrease.
Yeah, they'll decrease, because let's go back to our equation here. These go down by 10%, let's say. Pi I, then pi I goes down by 10%. So commodity prices would fall by the same percentage. And if wages were unchanged, or other income, then full income, remember, full income approximate, real full income is approximate this, if S is unchanged, all the pies go down by 10%, then some index over the different pies go down by 10%, and therefore this whole thing goes up by 10%. So an improvement in household technology raises income, full income, just as much as a 10% increase in S, in wage rates. Remember, S, simple model, S is simply no other income, so wages go up by 10%, S goes up by 10%. But the effect on full income would be exactly the same if all these AIs and BIs go down by 10%. What happens to the CIs? Well, real income goes up. So if you look now at the change in CI, say the change in S over pi, the change in CI minus over change in pi, right? That will be determined by the income elasticity, A, right? Income elasticity. So we would predict that the more educated people would be consuming different goods in relation to their income, different commodities in relation to their income elasticity. I'll come to goods in a moment. Okay, in relation to income. Now, so you observe, let's say you go out, you observe educated people, you find the more educated people, even if the wage rate is held constant, and it's a little tricky, well, why is it being constant? But let's not worry about that now. And they will consume different bundles of goods. They won't consume the same bundle of goods as less educated people, the same wage, therefore, let's say the same income. Okay? Now, two interpretations, at least two interpretations of that. One is, well, education affects your preferences. Okay? Number two, this interpretation, education affects your technology. How would you distinguish those? Well, if you can. Yeah.
It seems like you can always explain anything through changes in preferences, so the question is really, can you effectively explain it through changes in technology?
Okay, good stuff. That's a good start. And now let's take the technology. Do we have any predictions about this? I mean, what is it? I mean, how are we going to try to explain it with technology? So let's say you're looking, more educated, less educated. We look at their behavior. We think this is due to educated people have better household technology. They may also have better income, but we can take that out, the effects of that out. How do we try to look at it? That's right. That's a good start, but we have to go and make the next step now. Anyone? All right. What do we know? We say that if it's due to technology, the changes in commodity consumption, which should be proportional or determined by their income elasticities, right? So if health is very income elastic, then you should have a really big increase in health. Well, health we can actually measure as a consequence of greater education. And the interpretation would be you have more real income, you buy more health. Okay. Now, yeah.
That's if it's neutral across commodities.
Well, I'm assuming so. That's what I'm assuming.
Okay,
Okay.
yeah, if it's neutral across
No, I'm
commodities.
assuming it's neutral. Yeah, it's very important.
But it's-
Neutral across.
You can do it when it's not neutral too, right?
You can do it when it's not neutral. Let's start out with a neutral case. Okay. Yeah.
So can we measure educated and less educated people who use the same technology to see their outcome of home production, if there would be difference?
Well, if you could do that, that's not so easy to do, though, because the educated people have a better technology, right? So if you could do that,
If it's just a preference, they shouldn't have difference in the output, in the household output. But if it's a different technology, then educated people should have better output.
Z.
Yeah.
Yeah, but I mean, but we're going to see it's same. I mean, they have the same income, let's say. So the expenditure is going to be the same on the assumptions I have, right? Expenditures are going to be the same. The form of the expenditures are going to differ by education level. Well, suppose now you do an experiment and you look at the effect of changes in income, let's say for people of a given education level, on their consumption, their health, and so on. And you estimate the income elasticity off of that type of data. And if this interpretation of technology is the right one, you should find the pattern of changes. Let's say as your income goes up, you shift towards services and away from goods. Then you should see that the more educated people with a given income level, but have better technology, should be shifting towards services and away from goods. That would be a simple interpretation. And therefore, that lines up with what we know about income elasticity based upon changes in, let's say, in S or in wage rates. We can say, well, this may be mainly due to technology, even a simple model of uniform technological change, progress in all sectors. Now, I'll come to the moment when there's differential. Yeah.
But I don't see how you can really tell the difference because it's the way you interpreted AI and BI are technology coefficients, but if suppose they were also multiplied by some preference parameters, then you can't tell whether, like if you write down any utility function, you couldn't really tell if it was the preference parameters, gamma that
Well,
changed.
yeah,
or
but
it
remember,
was-
we're talking about shifting, we're looking at two groups, educated people and less educated people, same income and consuming differently. All right, so if all you had to do, explain that was within preferences, you have to say, well, somehow there's some differences in preferences between these two people. The question is, what theory would you have of how education changes their preferences? You have to have a theory about that. Right? Not obvious what that theory will be, right? That it will simply reflect. That's what this doesn't need that type of theory. Does need to interpret this in terms of technology. That's the difference.
If you get the preference theory that says educated people act as if they have 20% more of, their utility is the utility you would get if you had 20% more of every good, then it would be observationally equivalent to this. But also, I don't even know how it's intellectually distinct from this, right? I mean,
It's the same
I mean,
thing.
it's the same. I guess that's what I'm saying.
That's why I was asking, like, whether there is, it is a matter, I guess, of theory, of how, of not of interpretation, but I guess what's more useful for economists is what's
No,
more,
but-
because
So
fundamentally.
think of it
But
this
the
way.
key
Kevin.
is, though,
Think of it this way. Suppose you substituted these production technologies as the
Absolutely.
utility function. And you can interpret that this is shifting up your utility level.
exactly, but see, the key here is to link it back to what you could potentially observe. If you know that education makes you more productive using a computer, more productive doing X, because you can observe that in the market and other places, you have an idea about what the pattern of technical change should look like. Now, it's complicated to translate that into observable consumption. I think Gary's been talking
Yeah, I'm
about
going to
that.
talk about that now.
But the idea is, whereas preferences, you don't have that restriction. There's no reason that because education makes me better at doing X in the market, my preferences would shift toward I like X in the household. It sort of seems like, well, it could be a coincidence.
You don't have a guiding principle
I think
on the
that's the key.
preferences. Here you have some guidelines to do it. And I think that's the main distinction between the two. Now, I've been talking only about commodities. You might say, well, we might observe, we do observe, we've got measures of health, so we can look at the commodity health. We might observe, education level, you're investing in education and some other commodities. A lot of commodities, you're really not observing the output so well. It's not unique to household production. We don't observe the output of a lot of service sectors. How do you measure the output of a university? Not so easy. And usually they're measured by inputs. I mean, a lot of national income accounts, outputs of some of the service sector are measured by inputs. So suppose we look at the inputs now. Okay? And I'm going to do it in a particular context. Instead of dealing with general change, I'm going to look at health. Okay? So suppose we wrote we have the equation for health. Health depends upon it in general, some production function for health is a function. I'll play with these in a moment. So M is medical care, then some measure of medical care. X, various goods that may affect health. H, time, use for health, let's call this HH. Okay. E is education. And A is age. We have this production function for medical care. Let's say education, we have an increase in education. That only affects health. I mean, we could deal with all the others as well. But let's assume it only affects health. It only affects the productivity of the health sector. Okay? And so what we would expect would be, if this education is productive, that DE is greater than 0. So an increase in education affects health. Okay? As low as will lower the shadow prices. Think of it if you think of it in terms of the fixed proportions AI and BI, an increase in education will tend to lower AI and BI, or more general production function. It'll raise the average and marginal products of medical care, goods, and the like. Okay? So what would be the consequences of this? Well, in this case, we would get delta H, delta pi H would be less than 0. We'd have a substitution effect, right? Because pi H goes down, and so you consume more health, and there may be some income effect, or it might be small if it's only affecting the productivity of health, but it might be an income effect, assuming health is not a gifting good, seems reasonable to assume. Comes out of statistical theory of life under some assumptions, then you'd have this negative. So this would be your elasticity. Now suppose you ask the question, what's the effect on medical care? Your demand for medical care. What would be, how would you answer that? Let's say the CRS, so medical care could be any other input, and let's say education affects the marginal products of all these things proportionally. So think of, again, the fixed proportion case, increase in education. If this is health, let's say they thought of it in terms of fixed proportions case, and XH is equal to AH of health, and HH is equal to BH, function of education at health, and A prime H is less than 0, and B prime H is less than 0, so education lowers these coefficients, and it's proportional. Okay? So when I say medical care, I could be dealing with any other. What happens? You know they're going to be taking more health. Anybody? Well, does demand for medical care necessarily go up? Ashley, you're shaking your head. What do you think?
I guess I'm not sure about the implications of these assumptions on the technology for substitutability.
Well, then all the A's and I's and the BI's all move proportionally. Or if you had substitutability, that you shift, it's factor neutral. Right. Think of this as a factor neutral change. Maybe at Cobb-Douglas, and you have some general increase in productivity.
So I think it would increase the amount of medical care that we get.
Okay. Anyone else? Well, let's think about it. Okay. We have, suppose this.
Go ahead, you want to do that, or you want to ask them like an analogous question?
Well, let me do this. Yeah. Suppose this was 0, or very low. I mean, we don't think it will be 0. Suppose it's very low.
So are you saying people would use less medical care because for the same amount of health, it's now cheaper to
Exactly.
substitute towards?
They could get exactly how much more could they get? Well, if you had a 10% improvement in productivity, then for given inputs, they could get 10% more health for the same inputs. Okay? So we think now of why do I have this term here? Because this is a measure, the change in price is the flip side of the improvement in productivity. So a 10% reduction in the price means a 10% increase in productivity, right? By assumption, right? Or the AI, again, that's why it's easy to think of in this case. The AIs and BIs go down by 10%, so the price goes down by 10%, okay? So the 10% decline in price means a 10% improvement in productivity. So this, let's call this beta health. This is -1. So this thing is greater than or less than 0 as NH is greater than equal to or less than 1. So if it's exactly 1, so if the elasticity at 10% change in price leads you to a 10% increase in your demand for help, 10% more help. But we know a 10% change in price is equivalent to a 10% increase in productivity, and you can get 10% more help from a given inputs. So in that case, you have no effect, right? It's only you have an elastic demand. So demand for medical care could be going down. Demand for medical care could be going down at the same time, or other inputs, at the same time that health is going up. Now, it looks paradoxical. You have people healthier, and they use less medical care. Now, one interpretation of that, medical care kind of kills you, right? That's one interpretation of that.
It's true in the 19th.
Yeah, it was true throughout, you know, I had a teacher, famous economist, Frank Knight. He said he always asked doctors when he met them, when did you begin to save more patients than you killed? And they usually answered, well, we're not quite there yet. I think we're there now. So that's one interpretation. The other interpretation in this case would be, no, there's a joint variable operating on both. That education is leading to you to have more full income and more productivity at the same time. And so, given your response on health, you might not need as much medical care as you did before to produce that response. Right? And there's some evidence not inconsistent with this, and more educated people are definitely strongly more healthy than others. That's a very powerful effect for both men and women. In fact, the effect of education on life expectancy is greater for men than for women, even though women live longer than men by a considerable margin. But the amount of medical care taken isn't so obviously positively related to education. Educated people just do a lot of things just much more efficiently and more effectively. That's where the household technology concept comes in. You have to think about that and how efficient people are. Do they go to the doctors, right? Or do they forget appointments? Do they take their pills on time? And all the other things that we know people vary a lot in. Okay? Yes?
What are you thinking of as generating differences in educational attainment?
Good question. Kevin and I have spent a long time thinking about that question. So what's your belief? What generates differences in education?
I guess I'm just worried that if the picture is something to do with discount rates or expected lifetime, which could, in a traditional model, generate differences, then that's what you would expect without an effective education.
Yeah, it could be. I mean, that's why you have to try to just not look at some least squares relationship, but try to tease out the more causative side. But what is the main factors determining educational differences? Few things have been put forward and somewhat tested. Capital constraints. Some people don't have the capital. Their parents don't have the resources. Can't borrow on base of human capital. It's very poor collateral. So people who don't have access to non-commercial capital, like from parents, are at a disadvantage. Second major factor would be that if your parents don't invest in you a lot when you're young, it's very hard to make up for that later on. So early childhood education in terms of cognitive and non-cognitive skill development would lead then ultimately to lower education. So these are two variables. The third factor would be, well, some people have more general ability than others, and we know there's a strong correlation between things like IQ and other measures of ability and education. And then you have to worry, well, is that ability what's producing the higher earnings That's why there's been all this literature on how to explain the correlation between education and earnings. 50-year-old literature trying to tease out the effects of ability and signaling and things of that type. I mean, similar issues arise with regard to non-market effects. So that's why people try to look at people of very young ages who are similar health. How does that health evolve over time? Try to control for things like IQ and other measures of ability and things. Right?
This has some particular implications, right? I mean, it says, like, for example, if you have, because you can also measure the price elasticity. So it sort of says goods that are price elastic, educated people should do more. Goods that are price inelastic, they should use less. You know, not necessarily the discount rate or something will give you that same kind of pattern. And this notion that the elasticity is key really is important in so many areas of economics. It's like, you know, you make light bulbs last longer. People buy more light bulbs or fewer light bulbs. I mean, it's the same question. You know,
Yeah, this
all the-
technological question, there's nothing unique about it, as Kevin was saying, there's nothing unique about this problem. I mean, you've got technological progress in an industry, and you ask, does the industry use more inputs or less inputs? You have to go through exactly the same type of analysis, pretty much.
That question of whether the elasticity is bigger or less than 1 comes up so
Yeah.
many times, because it's always, any of these cases where you become more productive or analogs of that. You know, it's like we asked that question on the practice questions about quality. I mean, it's exactly that question. You could have the quality go up and you buy less because it lasts longer. So, simple
Yeah,
way
so-
to think about that. But
Yeah, this is answering one of
Yeah.
those questions.
But it pushes it, the key part is, it makes it related to something you can observe, which is the price elasticity. So if you can measure the price elasticity, you get a prediction. Just like Gary's earlier thing, basically you're saying when I change all prices equally, well then that's an income elasticity. I mean, this is saying when I change one price, it's a price elasticity. The other side of which is interesting is it also has implications for the substitutes and complements for this good, right? Because if this is what's going on, you're lowering the price of this good, which way it goes depends on the price elasticity, bigger or less than 1, but all the other goods should respond like they would to a price change. So the substitutes go down and the complements go up. I mean, it's got some pretty strong observable implications, I think, that come out, because it links the effects of, in this case, education to other measurable things, which are the effects of prices and income.
Yep, absolutely. Any questions? Yes.
Are the observed differences in health by education consistent with vague estimates of the?
Do they observe these differences?
Do the observed differences in health by education, are they consistent with our estimates of income elasticity?
Well, remember, it's a price, it may be mainly a price elasticity. Let's say if education has a bigger effect on your ability to produce health than it has to produce other things. In the case I dealt with here, I had only that. It's a good question. I don't know, if, at least I don't think I know the answer to that question. So the question you asked, what can we trace back? We know that educated people are much healthier, right? It doesn't seem to be a causation from health to education, but it does seem, let's accept for this that it is from education to health. We can isolate out the income effect, because you can look at people of various incomes, various wages, and try to hold that constant. So you have something left over. So either what's left over is a taste change, or it's a productivity change, right? And then you have to go to what extent can you predict what's going on. I mean, if it's a taste change, it's not clear what's going to happen to the inputs.
I think it's fair to say that there's a bigger effect on outputs than there is on inputs, which is consistent with
Yeah.
productivity going up. That there's a clear positive relationship with outcomes.
Yeah, that's what I was.
A much less clear
I was
relationship
leading.
on
Yeah.
inputs.
Yeah, because the taste change doesn't have a clear interpretation. I mean, if it's just taste, not obvious why input shouldn't go up in proportion to the output of health. But we do know that inputs may even fall, but they certainly don't go up anywhere near proportion. Right? So that suggests there's some kind of efficiency going on. Yes?
How would you incorporate information changes into this? Would it be in education or would it be in the AIs and BIs?
Well, I mean, it may be through education, or maybe through other variables that affect, information. So household gets more information for a given education, then you'd have the education effect entering into this, just like it would, let's say you have a firm that gets more information, you say, well, that affects the product, might affect the productivity of the firm. In this case, if it's information about how to produce this health from your inputs and market inputs, it would enter as one of the, some other factor that shifts technology. That's how you would do it.
Let me try to give you a slight answer to that, which is, we know education affects productivity. So, like, for example, we know that educated farmers produce more output than less educated farmers with the same inputs. And they could say, well, why? I mean, they don't drive the tractor faster, right? I mean, and the answer is they kind of pick their mix of inputs better than the other guys do. That is, and I think what you're saying is, well, maybe that's just information. Well, but education doesn't have an effect just by magic, right? It has to work through something. I mean, and to say it works through information seems to me to be just telling me how education does the work it does.
See, one thing there's a
Decision-making
puzzle
appears to
about
be
what
a
is liberal arts education or general education do for you? Why does it make you more productive? You can understand why an engineer is more productive. And until recently, why somebody studies finance is more productive. And lawyers, doctors, and so on. But what do you learn in liberal arts education? Well, a lot of things you learn, but one of the things I think you learn is how to process information more effectively than otherwise. You do exams, and you're processing information, you're getting information, but you're also learning how to process and utilize the information, how to find new information. So a lot of information operates through education. Not all of it, obviously, but a lot of it does operate through information. Maybe that's really what a lot of what you get out of schooling is learning how to handle information much better. So educated people have been an increasing advantage in the modern world where information not available, to how much information you have and how to get additional information is much more important than it used to be historically. So you find the spread in earnings between college graduates and high school graduates has gone up substantially. From like the differential on the average in the United States being about 40% in 1975 or so to about 80% now. So that's where, but maybe other sources, less educated people get information too. Any other questions?
You referenced that earlier example for farmers. Linus Welch did a pretty nice study of this. What he found was that if they used the same inputs, the educated guys and the uneducated guys got the same output. The difference was the educated guys tended to use the more appropriate mix of inputs for what maximized output. So in some sense, they had the same technology, they just optimized better against that technology, which was a nice way of saying, well, what did education really do for these guys? It didn't, it wasn't driving fast, it was better decision making.
Combination. So if you look at, when you write down a production function like this, say, well, given medical care, given other inputs, how can education affect my productivity? Somehow how I put all this thing together, we interpret it by saying, well, in the health area, we would say, well, yeah, even if I go to a good doctor, I don't follow their advice so much if I don't have the education. Or if I'm taking drugs, I forget that I don't think that's so important. I don't take the drugs. So if I just think of expenditure on goods, well, I'm going to worry more what's the cholesterol content of goods or the sugar content of goods. So that it's combining things much better. It's very much similar to the farmer.
Yeah,
Very much similar to the farmer.
You write down a production function, it really is the result of already a maximization problem. We just kind of never in economics talk about that maximization problem, which is how you got the production function for saying, because the production function is what's the maximal output I can get from a given mix of inputs. We don't spend a lot of time talking about that. Some people who do organizations do. They sort of that's the theory of organizations, talks about how you build a firm and you get the most output from a given mix of input. But most of economics kind of ignores that.
Doesn't deal much with it. Another point worth mentioning, I mean, distinguishing market sector from the household sector, which is important. In the market sector, you have people who generate specialized human capital. Maybe specialized by occupation, specialized by industry, specialized
Yes.
by firm even. So a lot of specialized human capital in the market sector. In the household sector, people, you don't have that much specialization. I mean, I mentioned yesterday the division of labor, so some specialization in household and market, but you have all these commodities. So you have more general, your general education is going to be relevant there, and it's not going to be as nicely attuned to any particular commodity as it would be in the market sector. That's the big difference. So we expect probably lower productivity in the household sector than the market sector. And there was economists who founded a National Bureau of Economic Research called Wesley Mitchell once wrote an article called The Backward Art of Spending Money. Now, to give that a more rigorous framework, I think this can provide that framework for it. It is a backward art, partly because you don't have all the specialized skills, because you have to cover all these different products with a small household. You can't have one member doing Z1 and another member doing Z2 and have 300 members. Now, why you don't have 300-member households is an
People have tried.
interesting question.
Not like they didn't try it.
Yes, thank you.
Because it worked so
It
well.
doesn't work well. Right. Any other questions? All right, let me give you two other things, and then we'll change. One, joint production. You recall, I assumed right at the beginning no jointness in production, no multitasking. Right? But obviously there are examples where that is important. And one example that's kind of nice is smoke. So in smoking, we would say smoking is an input into two different commodities. One of them is health, right? So we would have health. Now I write health function down again. Okay. Health. Health depends on all these things that I had before. And C equals cigarette smoke. And the characteristic of that, we would say, well, DFH, DC is less than 0. Get less health, you smoke more. Then you might ask, well, why does anybody smoke? Right? You don't get paid to smoke, you have to pay to smoke. And you have to pay increasingly a lot, and we've increased the taxes on smoke. So why do people smoke?
They get relaxation.
There's some other commodity. Let's say in this framework, we say there's another commodity. Let's call that, I'll call it relaxation. That's good. Your relaxation. So it's some compromise between these two commodities. So if you look at, you go back to our utility function, budget constraint, I won't write all that down, but a full income budget constraint, and you maximize with respect to the input C, what would you get? You get DU, DH, well, I call it DH, but H, DH, DC, plus DU, DZR, relaxing, DZR, DC, is equal to lambda times the price of C, right? So this term is positive, this term is negative from up there, positive, positive. And so you have a net utility. If that net utility, if this is negative, and this would be an inequality, and C would be equal to 0. All right, but it may be positive. So you smoke some, but you smoke less than if you didn't have the negative effect on health. Now suppose you have an increase in income, like an S. What's going to happen? Well, you're going to increase your health, presumably you want to increase your relaxation. So both these would tend to go up. What happens to demand for cigarettes? Not so clear. Could go down, right? It's good. It would go down if, as you increase your health, the negative marginal product of smoking really went up a lot. So, for example, if you had a production function, if H is equal to something like m to the alpha x to 1 minus alpha, minus beta, the beta is positive. So if m and x are increasing, that's making the marginal product of C much more negative, and could make it a lot more negative. So this term here could be becoming much more negative, and if that dominates any changes in here, you'll end up reducing your smoking, even though smoking was would look like to be a superior input. If you want to increase your relaxation, you want to increase your smoking. But because of the jointness in production, the effect on relaxation is dominated by the, could be dominated, this is necessary, but it could be dominated by the effect on health, and therefore you smoke less. So, I mean, common sense saying would say, well, we got more income, it's more valuable in terms of health, so we cut our smoking. Now, prior to the information about the link between health, negative link between health and smoking, there was a positive income effect. Positive income effect on smoking. The higher income people smoke more rather than less. When this information spread, talking about information, this is information that did spread more quickly to the more educated people, which is kind of interesting. Low educated people are the slowest to acquire that information. And then now, if anything, we see a negative relationship with income and smoking.
So there could be a couple of major things going on, right? One could be that there's a greater income elasticity for health than there is for relaxation. The other thing could be there could be more substitutes for relaxation than there are for producing health in cigarettes. Right? There's a lot of things that could be driving that.
Yeah, like in this production function relaxation, which we have here, well, you know, you shift toward the XR.
Yeah, exactly. There's a lot of substitutes for relaxation.
You get drunk rather than smoking, or you eat a lot.
Right.
You know, all these alternatives.
Yeah, that's key. I mean, it turns out the degree of substitute for each are going to limit how much these prices can change, right? And so if there are a lot of substitute ways to get relaxation, then the price of relaxation can't change much. But if there's not much substitutes for health, ways to produce health to offset the cigarette effect, then you're going to really have to cut back on cigarettes in order to get a growth in health. If you sort of have both wanting to rise with the income effect. So again, you got to come back to think about substitution and income effects really tell you what's going on. And rich people, you know, instead of smoking cigarettes, they do lots of
Yeah.
other things to
Right.
provide relaxation.
Yeah, definitely. Such as working. All right, so any other questions on this? Let me come to my last topic. I want to deal with this, and a lot of you are interested in this. Behavioral. Some comments on how you link this to some things in behavioral economics. Now, the household production framework provides a way of thinking about questions in behavioral economics, like cognitive skills. People get fooled by small print. You get fooled by fast-talking mortgage salesmen. You get fooled by whether you ask to be opted into something, like a pension plan, or opt out, or into another area where the opt-in, opt-out is used across different countries in different ways, is whether you'd be willing to give an organ for a transplant. Let's say if you died, if you don't opt out, then it automatically says you are willing. That's one approach. The other approach is you have to, as in the United States, you have to say, you have to opt in, you have to say you are willing. And responses are different depending upon these way, how you put, whether you have to opt in or opt out. Okay. So now with household production, I like that way of looking at some of these problems. First of all, because it seems to incorporate a lot of what we say, that some people have poor technologies, poor information, so they're not very good at achieving the goals they would like to achieve, at least some of the goals they would like to achieve. They like to borrow money, but they borrow, they don't recognize that the interest rate will kick in right away, or it's a high interest rate. And so they borrow more than they would borrow if they had more information, if their information in their production, or whatever they're using borrowing for, was great. So that would be a way of interpreting that. Maybe due to low education levels, ability levels. Usually, it's related back in good part to education. That said, in the recent housing difficulties, the low educated people were misled into taking out mortgages that was counter to their interest. Now, whether that's the right interpretation, another question, because they were getting low interest rate mortgages with very low down payments. It wasn't really a bad deal, but maybe there was something to it. Okay? So, what are the consequences of this, as we would assess them here? Well, on one hand, we would just go through our analysis before it would show up in poor personal management. So, production functions are inefficient. Your real income is low. You're not teasing out high levels of productivity. So we would say these people end up less efficient, and I think that partly is partly the case. They don't see doctors when they should be, and they don't recognize symptoms of major diseases. Okay? And they borrow more on credit cards than they would like if they had more information. And that's usually where much of behavioral analysis ends. Not in this framework necessarily, but reaching related conclusions. But there's a major qualification based upon the kinds of things we were doing earlier in the week, and that all of you know, and hopefully before were familiar with, and that's how markets respond to that. What are you had competitive forces, how does that work out in a market? When there's supplies, there's a supply side to this market as well as a demand side. So take the credit card case, for example. Assume you have low-educated people who get fooled into borrowing too much, they can't calculate interest rates because they haven't read the fine print, so we are moving or have moved already, but the print has to be large and they have to be reminded. Okay? Well, on the supply side, the banks issuing credit card to the extent that people are borrowing more than they would have if they had more information, it's more profitable to be supplying credit cards. And what does that do? Well, that leads to an increase in supply of credit cards and of credit to consumers. As the supply increases, that pushes back somehow the full set of prices that individuals are paying. So they may get like credit on frequent flyer miles, offer that as an inducement for them to take out their credit card. They may have their fees and the annual fees waived as a competitive advantage. Gifts, you may be able to accumulate gifts. And a variety of things like that. And to the extent that banks are in a long-run zero profit equilibrium, whatever gain the banks make, so to speak, in a short run, they give back in the long run through the competition over profits. So consumers may not be that much worse off net as a result of this, okay, in equilibrium. A diagram, one simple diagram for illustrating this would be the following. Suppose you have a commodity. This is the demand curve for this. If, let's say, full information, quantity consumed, price. This, poor information. The short run of supply is here, short run supply. And so, given the limited supply, the fact that they demand more because they really don't recognize what they're getting, price seems high. And this is a first order. This higher price is a first order cost to the consumer.
So they lose that corresponding rectangle.
Yeah, this rectangle. Now, what happens in the long run? Well, in the long run, supply is much more elastic, right? Because there's entry. So let's say, take an extreme case, long run, which this is the supply curve, long run. And my view, for a lot of commodities and a lot of goods in the market sector, the long run supply is really pretty elastic. You can get a lot of resources flowing into an industry at pretty similar costs. There are exceptions like the oil industry because there's a natural resource that limits the flow in. But in reproducible goods, elastic long-run supply is a pretty good approximation, I think. All right. So what's going to happen? In the long run, they're not going to pay anymore. The increased competition is going to beat down the price. As I said, they'll get no fees, gifts, all these other things. Now, they're taking more, so that may be costly. On the other hand, we know to a first order effect, increase in consumption around this equilibrium has no cost, right? So if you're around a maximization point, you took a little more consumption of one but a little less of the other, you have no net change in utility. It's only a cost of the second order. So if demand is pretty inelastic, as is often claimed, and this is elastic, yes, this second order may count for something because it may be big, but it may not be very large.
To give you guys a problem on that, did somebody calculate that? I asked you a question, if Guy knew the value of something plus or minus 20%, wasn't that one of the questions? How much would he be willing to pay to learn the truth? Did anybody calculate the number?
I think it was a true-false question.
You had a
It was a true-false question, so you all said false? Well, you had to calculate the number don't you have to calculate the number to tell you how to answer the question?
It just said substantial information costs.
Yeah,
It
so
implies
so what would you say?
Well, I said true, but now I probably would say false.
Well, let's calculate the number. How would you calculate the number? It's your triangle, right?
Yeah.
How big is it? I gave you what, plus or minus 20%? So let's do the 20% number. 20% is a pretty big number. So there's a little triangle there to the right,
Yeah,
right?
yeah.
Below the supply curve, above the true demand curve. No, it's the other one.
What?
It's below the supply curve, above the true demand curve.
Yeah,
The two are the same size.
This one here.
Yeah.
Yeah.
That's
You're
right.
pretty close to being the same.
How big is that triangle? Well, the height's 20% of purchases. The width is 20% of purchases times the elasticity of demand. So let's just use, I don't know, half the elasticity of demand. So that's 10%. So 10% times 20% is 2%. It's a triangle, so it's a half. I mean, half that, so it's 1%. So whereas Gary's original box was 20% of expenditures, what you would only need the information cost to be 1% of expenditures in that. And I said plus or minus 20, which kind of means like if you thought about a normal distribution, a standard deviation of 10%, which would only be a quarter of the number I just calculated. So it would have been actually a quarter of a percent would be the amount of you'd be willing to pay to learn. So it's pretty small.
And you can see in this example, that triangle is a lot smaller than the rectangle.
Yeah, I mean, it's an
And if
interesting.
you kept, if demand is pretty, if demand became more inelastic, it would be really negligible importance, all right? So, that's what market forces would be doing in this case. So one other point, I'll come back to your question. So, what does this say? Well, it doesn't say that, that kind of weak productivity being misled has no cost to consumers. But it does say, and I think this, I find a serious limitation in most of behavioral analysis, and much of the analysis of an experiment, either a lab or a field, that unless you put it in some kind of equilibrium context, not only for the individual, but also for the market, it's hard to assess how costly that is to the individual, because you don't need both sides of the market to be informed in a competitive structure to get a solution that's pretty close to fully informed.
Fully informed in terms of welfare.
Welfare.
But you should be able to, the interesting thing about this is this implies, Dick Taylor and Cass Sunstein have this book called Nudge. This to me is always the theory behind Nudge. It should be easy to push people a little bit, right? It doesn't
Yeah.
cost them a whole lot to move them a little bit from where they want to be.
Exactly.
Because they're maximizing,
Right.
so
Yeah.
like, that you should be able to nudge them around a little bit, push them a little to the right, push them a little to the left. They don't lose very much, or alternatively, they don't gain very much by trying to figure out whether that's right or not.
But the important point is they don't lose very much by being nudged.
But so you have both observations. You have the observation that people should be nudgeable, but then you don't want to infer from that necessarily that costs them a lot.
Yeah, that's the important
It's
point.
an interesting,
Yeah.
so it kind of, I think, positive story is it kind of makes the nudge kind of stuff more plausible.
Right.
But it kind of changes maybe a little bit your interpretation of the implications.
Yeah.
And not just a transfer between from less informed consumers to more informed.
Well, it depends to what extent the suppliers can separate out the two groups. Let's say, if you think it's due to low education, then you know that low education people are borrowing on credit cards, the high educated people are paying it on time. So you make more profit in the short run on low educated people, but you increase the supply of credit cards